Hi there, my name is Ron Rogers, and this presentation is titled, A Mysterious Fatal Accident That Took Years to Understand, How Entrenched Biases and Scapegoating Can Impede a Difficult Investigation. Now, in most investigations, the groups will come together. You will have structures, engines, flight control, pilots group, the manufacturer, the certification authority, and most of the time they come together and they work very well together because you often quickly assess what the primary cause for the accident was. You can get to some pretty good ideas pretty quickly, and everybody works together to find the cause. The accidents where it's not coming out what the cause is are the ones that cause problem. That's when everybody pulls back and entrenches in their silos. It's not the pilots. It's not the airplane. It's not the manufacturer. It's not the certification authorities. They're all pointing at somebody else. And that is not very productive. And that's kind of what happened in the case of the 737 rudder issues. Now, those of you who have been following my channel know I've got a background in flight test from the Air Force, out at the Air Force Flight Test Center. I worked for Boeing in flight test, and of course, quite a bit of time, several decades, with when I was an airline pilot, offering my volunteer services for the Airline Pilots Association. I was chairman of the Airworthiness and Performance Committee, the New Aircraft Evaluation and Certification Committee. I got my credentials as an accident investigator, worked for the International Pilots Association, and later these committees were put together into aircraft development and evaluation programs, and I was the director of that. Now, in the 1990s, there was a bunch of problems with the rudder on the 737. They had a number of incidents and two separate accidents where the pilots lost control of the aircraft due to sudden and unexpected rudder movements, resulting in crashes. And these crashes killed a total of 157 people. The first one of these, and this was really baffling. It was a United Airlines flight 585 that occurred on March 3rd, 1991, going into Colorado Springs. It was going in there and crashed while attempting to land. And the NTSB investigated the accident, but they're unable to conclusively identify the cause of the crash. And this is where things kind of got interesting. They were coming up with, and anybody who flies into Denver knows that the winds and the weather can be quite interesting and quite unusual. And they were talking about a horizontal vortex that the aircraft could have been caught into and spun out of control. They were talking about possibly a rudder issue, but the power control unit, the PCU, was so severely damaged that they couldn't identify or couldn't evaluate it appropriately to see if it was malfunctioning. There were even some just wild speculations between the crew I don't want to even get into, because this is really fishing and it's really inappropriate. Now, this aircraft, United Flight 585, going into Colorado Springs, like I mentioned, impacted at nearly an 80-degree vertical angle. And this occurred on March 3rd, 1991. Now, what's interesting is, leading up to this accident, there were several incidents. On February 25th, 1991, the aircraft was flying at 10,000 feet when the rudder abruptly deflected 10 degrees to the right. The crew reduced power and they were able to regain control. A similar event occurred 2 days later. 4 days later, the aircraft crashed. And I know of other incidents. I had a captain friend who was doing the flight control check, taxiing out in a 737, and the controls jammed. And of course, he went back and rode up the aircraft. 25 people died in this accident. They never really found the cause, never really were able to determine. And part of the problem with that accident was the fact that the recording flight data recorder system at the time was very primitive. It did not record very many parameters, and it did not record them very often. But the most famous accident, and the one that really led to finding out what was going on, of course, was the U.S. Air accident 427. And that is when everything came together and a lot of the finger pointing started. Now, the second accident occurred on September 8, 1994. This was U.S. Air Flight 427, a Boeing 737-300. It crashed near Pittsburgh. It was approaching Pittsburgh Airport, and it suddenly rolled to the left. The pilots were briefly able to roll the aircraft right and level the plane, but then it rolled left a second time, and they were unable to recover. They impacted at a very high angle, and it killed all, obviously, 132 people on the aircraft. And again, as I mentioned, one of the problems facing investigators was the lack of the precision in the flight data recorders. There's been and had been a push for better flight data recorders to assist in these accidents, because if you don't have good data, if you don't sample it at a good interval, you just don't get enough information to be able to find out really what's going on. Now, while this was going on, and the NTSB was conducting its longest accident investigation in history, over 4.5 years, there was an incident with an East Winds 737. Now, this aircraft was Flight 517, and it briefly lost control of the aircraft while flying from Trenton, New Jersey to Richmond, Virginia. The aircraft experienced 2 episodes of rudder reversal while on approach to Richmond. And unlike the 2 prior incidents, the rudder issue spontaneously resolved, and the pilots were able to safely land the aircraft. Only one of the 53 people on board was actually injured. And the NTSB was able to get a lot of information by looking at the power control unit on this aircraft. Now, in interview, the East Wind pilots reported that they had not encountered any turbulence during the flight, but as they were coming down to land, they felt a rudder kick or bump, even though neither pilot had moved the rudder pedals. And the airplane abruptly rolled to the right. The captain applied left aileron and attempted to move the rudder, but the rudder pedal controls felt stiffer than normal and didn't seem to respond to his input. When the flight controls didn't immediately respond, he advanced throttle on the right engine in an effort to compensate. Now, like I mentioned before, the power control unit from 585 was too extensively damaged that it really couldn't be tested to determine the manner. But now they had the East Winds PCU. And what they were able to find out, and it's always great to have a survivable incident where they're able to get more information and determine kind of what was going on. And what they found out was that under certain circumstances, the power control unit's dual servo valve could jam and deflect the rudder in the opposite direction of the pilot's input. And they found that if you took the power control unit that had cold soaked, typically at altitude, and now you injected hot hydraulic fluid into it, it could cause the secondary slide to jam. And you notice most of the diagrams that you get in the training manuals are fairly simple. These devices are complex. Just go look in any wheel well of a 737 and you get an idea of just how complex these systems can be. Now, the 737 rudder design was unique. It was not like other large transport aircraft at the time. It was designed with a single rudder panel. You notice that rudder panels are often split on a lot of aircraft, and a single rudder actuator. And this single rudder panel is controlled by that single rudder actuator. Now, on March 24th, 1999, after a 4-year investigation, the NTSB issued the probable cause finding for Flight 427. They concluded the probable cause was rudder reversal due to PCU servo malfunction. 2 years later, the NTSB published an amended accident report for Flight 585 that found the same probable cause for that accident as well. As a result of the NTSB findings, the FAA ordered the servo valves be replaced on all 737s by November 12, 2002. And I must say there was a very senior Boeing executive who argued that this was still unnecessary and that the funds could have been better spent elsewhere on other safety improvements. Now, you can see the old system here. They have the green and yellow elements. The main power control unit controlled the rudder's movement using a single dual concentric valve and input arm. The new system with the red elements adds 2 independent valves and dual input arms. The input arms also contain spring overrides that allow the system to operate normally if it becomes jammed. Hydraulic pressure sensors have also been added to activate the standby power control unit if abnormal readings are detected. Now, as the investigation progressed and it was difficult to determine the probable cause, this is when the entrenchment started. Boeing test pilots, and there was one test pilot named Mike, and Mike was rather pejorative towards airline pilots, rather dismissive, and he was talking about your average airline pilot. And of course, 90% of all pilots will tell you they're above average, and as you know, 85% of all statistics such as this are made up on the spot. But nobody admit to being an average pilot, and after the meeting we went up to him and said, "Hi, I'm Ron, average pilot." And I think he kind of realized he had kind of insulted us. But what the Boeing test pilots did was they went into the simulator. Okay, this wasn't a 7th leg of a 4-day tiring trip going back and forth with weather fronts, dealing with passenger issues, maintenance issues, all sorts of stuff. These guys were rested, and they go in the simulator, and there's a thing called 190 knot crossover speed. Above 190 knots, the ailerons and spoilers can overpower the rudder essentially, and if you're above that speed, you can recover. And the Boeing test pilots went back and redid this accident and found that, yeah, they could recover. Okay, that's wonderful. But the NTSB kind of commented that no airline had ever trained a pilot to properly recover from this situation. And the pilots on Flight 427 had just 10 seconds from the onset of this to effect a recovery. And after that, the recovery was impossible. Now, what they did was they had the power control unit off of Flight 427. It wasn't as damaged as 585, so they could run some tests. And they found that the PCU was a little more sensitive than other similar PCUs when they ran it on the bench. And they set up the specific conditions that they felt caused the secondary slide to jam, and that was hot hydraulic fluid in a cold unit. Now, they interestingly found that this incident of the jam slide occurred in less than 1% of the tests. And after the slide jammed and the unit went back to operating normally, there was no evidence, no witness marks anywhere on the system to indicate that the slide had actually jammed. Well, Boeing felt that these tests were unrealistic and inappropriate given the extremes under which the unit was evaluated. See, here's where they're entrenching and saying, it's not ours. And the FAA's position was that sufficient probable cause didn't exist to blame the rudder control unit. Now, the FAA, the head of the NTSB, the head of the FAA went against the NTSB verdict, and that was Tom McSweeney. He's the director of aircraft certification. And he came out with a statement the same day the NTSB report came out and said, "We believe as such and we have studied this aircraft and the rudder system, and that these actions we have taken assure a level of safety commensurate with any aircraft." So the FAA evaluated the aircraft, and it was fine. That was a very unfortunate attitude. However, they later changed their attitude after the Special Task Force, the Engineering Test and Evaluation Board, reported in July 2000 that it had detected 46 potential failures and jams in the 737 rudder system that could have had catastrophic effects. And in September 2000, the FAA announced that it wanted Boeing to redesign the rudder for all iterations of the 737, affecting more than 3,400 aircraft in the United States. Boeing still maintained that the most likely probable cause was his co-pilot, and this is on 427, inadvertently deflected the rudder hard over in the wrong direction while in a panic and for unknown reasons maintained this input until impact with the ground. And Boeing finally agreed, though. They were basically forced to redesign the rudder control system. But like I said, there were people in Boeing, even after all this came out, who wouldn't accept that it was their problem. Now, what's interesting is there have been no rudder incidents since the redesign was implemented. Of course, we all know that the 737 has had a few other issues later on, and totally different situation here. But this was a case where we had trouble figuring out what was going on. Everybody started to entrench and blame everybody else. You know, the FAA certified it properly, Boeing built it properly, we designed it properly, that was a good unit, and you guys put it under extreme testings. But I think the proof is in the pudding, in the fact that they did find a method under which the power control unit failed, and they did rebuild them, and they have not had the problem since. Anyway, thanks for watching. I hope you found it informative, and talk to you later.